Hi, good morning, good afternoon, or good evening to all, wherever you are watching this right now. Thank you for joining. My name is Romain Decker, and I'm working as a product manager at SpectroCloud. I will be presenting today on software bill of materials, or you may also hear about SBOM, and how this concept can help you to manage your security attack surface and in your Kubernetes clusters. So a software bill of materials is one of the most important concepts you need to know to manage the security in your software supply chain. In terms of agenda, I will start with the current state of cloud-native apps and the challenges they bring. Then I will get into what SBOM, so software bill of materials, are and why they matter in terms of security, in terms of dependencies. I will also present some cool open source tools and do a live demo. Let's cross fingers that the demo goes are with me. And finally, I will present our new SBOM scan capability in Palette, our product to manage Kubernetes clusters at scale, and how to use it to manage your security attack surface. And I will also do a second live demo on that. So by the end of the webinar, you will have a better understanding on how SBOM scans can help your organization to stay secure and compliant. In terms of housekeeping, we can keep this interactive. You're all muted by default, but there is a question section. You have a small question mark icon. So if you have any question, please drop them in the question section and I will try to answer them. Recording and slides will also be available after the webinar. So software is changing traditional businesses and industries. Software is eating the world, and cloud-native applications changed the software landscapes. It didn't come only with benefits, it created new challenges. And really, to understand that, let's take a step back in the past. So applications are changing. In the past, let's say 20, 25 years ago, we had that concept of client server. So most of the time when you had to deploy or to install a new application, you were basically purchasing or deploying a new physical server or bare metal server, potentially multiple of them if you needed a treaty applications or a DB server and so on. It was a lot of manual actions, a lot of hardware actions. You had to rack the servers, patch the servers, install the operating systems, and so on and so on. Then with x86 virtualization, with VMware, Xen, Hyper-V, and so on, we gained in agility. So it was easier to deploy new virtual machines and by extension, to deploy new applications. It brought day-to operations changes because people that were used to deploy physical servers and install applications there were not used to deploy virtual machines so fast. And containers already existed at that time, but it was merely LXC or other systems, so not as easy to use as Docker images and Docker in general. But then Docker arose, and it really brought that simplicity and ease of use for developers. But then developers, they had that it was more easy for them to develop and deploy applications on their laptop or development environment, but then they had to push into production. So to manage containers at scale, we had multiple options initially, Mesos, Swarm, and Kubernetes. Kubernetes is today's the de facto standard, industry standard to manage containers at scales. So applications are changing. The frequency of the deployment is increasing while the average size of the changes in the deployment is decreasing. What else? Applications becomes also more and more complex. They have many dependencies, many libraries that may come from all over the place and having different levels of code hygiene and update cycles. Most of the time, the application as a whole is not under full control. Dependencies in cloud-native applications can amplify risks. And so do you really know what's in your software? Today, open source is everywhere. It's almost in all proprietary code base and community projects. For organizations, the question is not if you are or are not running open source code, it's what open source code you're using and how much you're using it. So if you're not aware of everything that is in your software or in your software supply chain, an upstream vulnerability in one of the dependencies or in one of the third party can affect the application. So software vendors often create products by assembling code source and commercial software components together like Lego blocks. And that's a XKCD cartoon, which I like a lot. It may be funny at first look, but it's not close to reality, but somehow it is as well. I have a few examples, like if you remember the Heartbleed bug in 2014 or 2013, which compromised the security of hundreds of thousands of millions of sites. It was caused by a problem in an open source library, OpenSSL. And at that time, that library had only a single full-time developer to maintain that library. So we relied on a single full-time developer for all those millions of websites. Another example, curl, which is used often by two systems to communicate together, is almost everywhere in each smartphone, smart TVs. It's present in more than 100 millions of cars. And it was developed by a single person. Now there are multiple people contributing to that community project, but initially it was a single person. NTP is more than 30 years old. So the code base is really old and it's not really maintained as much as we do, and it's used by several millions of systems. So, and what else? Well, also security. So security, the cyber threats are never slowing down. They are only increasing. So the common types of security vulnerabilities can be misconfigurations, exposed secrets, encryption, so lack of encryption or poor encryption, out of date or unpatched software. How do you know that one of the components that you're using for your applications or for one of the applications that you are running is completely patched for all known vulnerabilities, malicious insider threats, and so on? So security is complex and it's not always easy. So it may be funny to have that kind of security to like a single door with no fence for land, but the security is like this. It's very complex, but there are solutions to help you really to understand security as a whole. So in a nutshell, the business needs to bring new applications to market faster, to innovate with new tech, to gain advantage for the competition, and to respond quickly to customer demands. And on the other side of the balance or the equation, the IT needs automation to support agile applications and to simplify and automate operations management, including software security. So how to do that? Well, here comes bill of materials or software bill of materials. In terms of definitions, it's like cloud computing. There is no real definitions that everyone use, but I've added two definitions that are most often used. So a software bill of materials gives you the visibility into all the components that makes your applications. It details the third-party components and the dependencies used in the software. So it helps ultimately to understand the dependencies and to manage the security and compliance risks in the software supply chain. So it kind of serves like a recipe for software developers. It can enable them to understand really the application structure. So they are important. So software bill of materials are important because they provide many different components and dependencies from various sources. And it helps you to understand them. So why do you need them? Well, obviously first for security. It helps to understand how to secure the software supply chain. Second, compliance. it helps a company to really to comply with regulatory requirements. I don't know, GDPR or PCI or any kind of compliance that you have to rely upon for certain criteria. Dependencies, it's to identify the underlying components. So your security is inherited from the dependencies of your software. And finally, the cost, because a lot of time you can reduce development costs by identifying redundant or unused dependencies in software. And it's not just a good idea. It's also, if you're a US company, it's also a federal mandate. So according to President Joe Biden's 2021 executive orders on improving the nation's cybersecurity, it's mandatory now. And they define a software bill of materials as a formal record containing the details and supply chain relationships of various components used in building software. Well, it's especially important as with open source software developers and vendors often create products by assembling all those components together. In terms of format, the formats need to be defined so that machine processing and automation can happen. It means that it needs to be a consistent format. So the space is rapidly evolving, the landscape is rapidly evolving, so there is no formal consensus around which format is the best, but the three main formats are SPDX, OWASP, Cyclone DX, and SWID. The two main ones are SPDX and Cyclone DX. So SPDX is JSON-based. It's widely used by organizations and governments. It has been around for longer than the others. And Cyclone DX is an XML format, and it provides a standard representations of the components and metadata. In terms of examples, who doesn't remember the Log4Shell? So that was in December 20, so it was 18 months ago. So December 2021, like around Christmas time, people that had softwares that consumed Log4j, which had so Log4j had a software vulnerability so it's a Java library for logging error messages in applications, and it was a 0-day vulnerability. So when the CVE came out, it made all the news and so on. But for enterprises and organizations, they wonder, like, how do I know if I'm running Log4j? Well, because I have custom off-the-shelf applications, I'm running those paid applications that I paid for, and I'm running those applications, those open source applications. So how do I know that I'm affected by the CVE or not? Well, a software bill of materials scans could have helped them to understand if they are affected so that they can take the appropriate actions to remediate. In terms of tools, there are popular open source tools, many tools to generate software bill of materials, but most of the time they are categorized in two main buckets. So I only provided a few examples here, 5 examples. So the buckets on the left is the software bill of materials scanning. So that's really tools that helps you to understand dependencies. So you have Kubernetes BOM, so it's BOM CLI, BOM. It's a CLI that lets you create, view, and transform a bill of materials export as a JSON. So it was initially created to understand the bill of materials of Kubernetes, the project itself. You have Turn also, and Sift from Anchor. So Sift, for example, is a CLI tool and a Go library at the same time. It generates software bill of materials from container images or file system. Then on the right, you have vulnerability scanning. So you have Aqua Trevi from Aqua Security. It's a security scanner for container images, Kubernetes clusters, file systems, Git repo, you name it. And Gripe. Gripe is also from Anchor. It's worth noting that Sift and Gripe can work together. So you can do a bill of materials scan, and with the export, you can ingest the export directly to the JSON file in Drive to also scan for vulnerability at the same time. So now let's switch for a quick demo of those open source tools. In meantime, let me know if you have any question. I will share now my screen. So the BOM itself is just a CLI. So you have some actions. So I can do BOM generate image AMD, for example, Nginx, and I take the latest. So it will download the Docker image. It will unpack all the layers, so all the file system layers, and it will just provide a raw output of all the dependencies and the metadata. So you can see that you have relationships. So it looks like a bit complex here. So I can pipe this maybe in another command to outline, to have a summary of those dependencies. So it will do the same thing, but present by layer which dependency you have. So you see that it's just the Nginx, it's SPDX format. It has 6 layers, and it has hundreds of relationships. So that layer only has 141 relationships. So you can see which packages and so on. So that's only a summary. If you export it as a JSON file, you can really assess exactly what is used. So that's Kubernetes BOM. Now we have Trivy from Aqua. So Trivy helps you to understand really to scan for vulnerabilities, so for CVEs, for container images, for Kubernetes clusters, for Git repo, file systems, for file only, and so on. So I can do, for example, just like I did for the Nginx image, I can do image. Let's do Python, and then maybe 3.4 from Alpine. So it will do the same thing. It will pull the image, it will analyze the image, and it will expose all the CVEs inside the image. So here you have, for example, for the Alpine part of the image, so from the base, you have all the CVEs, so the vulnerability, the installed version, when it's fixed, and you even have links directly to explain the CVE. And then you have the same for the Python package. And it's available as a CLI, but it's also available as a Kubernetes operator. Now, that's only CLI tools, but what if you want to have, for example, a CI/CD pipeline? So here I downloaded and I cloned actually the example voting app from Docker that I pushed to my Kubernetes cluster. I have a CI/CD pipeline that I have here. So I have scan. So you have out-of-the-box GitHub actions that you can use. So for example, the SBOM action is using Anchor Sift to really how to assess the bill of materials of the applications. So I can just do that, but what I can also do is expose that directly to Drive. So if I add that piece, it will not only create this BOM file as an spdx.json, but it will also check for CVEs. So if I do that, I push, and I say demo1, I commit, I push, I will have my GitHub action that will trigger here in a second. Here, that will check my Git repo, if my Git repo contains any vulnerability. And if it contains any vulnerability, I can decide whether I fail the repo action. So I fail the following actions, so the following jobs, or runner runs after that step, or if I can just provide an email with the output and so on. So in that example, I just have the SPDX. Apparently I have no vulnerability. I can just check that. So the SBOM, I can unzip that and I can open with the studio code. And that's the JSON file. So you see that it's exactly all the metadata of each layer, security, which packages, and so on. What I can do also with 3D is check images. And so that particular image, it's Node 10 Slim. I know that it has a CVE. So I can do a demo 2, I can commit, and I can push that, which will generate or trigger a new pipeline action. So in my new pipeline, I still do a SBOM action and then scan image. And then by default, it will fail if the severity if it contains a severity which is medium level or higher. So I will double check here. I run here in actions, demo 2. So I have the 2 concurrent jobs that are running. So check code is still, so my repo is still running with no CVEs. And check image will fail because the Node 10 contains at least one vulnerability with level medium or higher. So that's a good way to check for your code or for the base of your code, which are the images that you're running. So when you do a Docker file, for example, you do from Alpine or from Node 10 and so on and so on. I can check here. So that failed. And I have a step in my pipeline that can check the view the report. So that's the JSON format help output, and I can check the CVEs. Okay, so that's it for the demo number 1. I will switch back to slides. So open source tools are fantastic, but you still have some efforts to build, so like DevOps effort to build and to integrate with the tool of your choice, whether it is CI/CD pipeline on GitHub, GitLab, or others. And even when the pipelines are configured, additional thought is required still to understand that in a human readable format, because remember the output format, SPDX and CycloneDX, they're really meant for machine processing. So here comes Palette. In the world of Kubernetes, organizations need to address a new set of requirements for Kubernetes at scale. And this is exactly what we have built at SpectroCloud, a Kubernetes management platform named Palette that enables teams to deploy and scale from 1 to thousands of clusters across any kind of environment, whether it is public cloud, data center, edges, and so on. And to manage consistently everything from the operating system to the Kubernetes version, and with a complete choice on what operating system you want to run, what Kubernetes distribution, what Kubernetes version, what kind of integration you want on top of it. And you can do all of that with zero trust, role-based access controls, governance, cost visibility, quota control, and so on. So really, Palette helps you to do all of that without creating any additional work for your team. It goes from day 0, designing, day 1, deploying, day 2, operating at scale across any kind of cloud. So you model everything into cluster profile, which can be managed as a desired state for your Kubernetes clusters. And we already supported scan for Kubernetes configuration security, conformance, and penetration testing. And in 3.2, which we released in February 2023, we added a new software bill of materials scan capability. How does it work? Well, we identify every unique container images within a chosen scope, and we generate a software bill of material for that image. We also run the SBOM through a vulnerability scanner to flag any known CVE that you would potentially be exposed to. So we leverage 2 open source tools sift and gripe, just like I showed in the CI/CD pipeline, but we do everything from the UI, or if you want, from the API. And in terms of configuration, it's very easy. So the feature, you just select the output format, Cyclone DX, SPDX, Sift, and you select the scope, if it's a complete Kubernetes cluster that you want to access, a namespace, one single pod, or a selection of pods using a label. And the backup location is optional because the raw data, the raw SBOM in JSON can be quite heavy. We want to host it into an AWS S3 bucket. So if you don't have a backup location, the scan will still run. You will still have access to metadata, vulnerabilities, and so on. But you won't be able to download the raw output of the scan. And scan can be triggered via URL or API. So you may wonder, why do you want to run that? If you integrate with Palette, you have all those benefits that you have from Palette, from day 0 to day 2 operations at scale across any kind of environment. And it's very easy to configure. You may run applications that you have not developed in-house, that maybe just a customer or maybe an internal team just running on top of your Kubernetes cluster. So there's no way for you to inject something in the software supply chain security. So it's for existing applications that are running. So I have another demo now for Palette. Directly, I will share my screen here. I'm sharing the entire screen. So I have a Palette instance here that I have multiple clusters running on. And I can just go inside one of my cluster. So I have multiple clusters. So I have 2 on AWS, 2 on VMware, 1 Edge cluster, but I could have all the others on Azure, AKS, EKS, GCP, and so on. So I will pick this one. It's running, it's healthy, it's running Kubernetes 1.24.10. That's my cluster profile. So it's the desired state of my Kubernetes cluster. So it's Ubuntu 20.4, Kubernetes 1.24.10, Calico, EBS, and I just have an LB for AWS. In terms of scan, it's very easy. You just have to go to the scan tab, and you decide which scan you want to run. For us, we want to run software bill of material, SBOM, and you can configure the scan. So as I mentioned, you just select the output format. Let's pick just this one, the scan scope. I will go for namespace. I will select the guest book. I will select the backup location, which is an AWS S3 bucket, and I confirm. So it's scheduled, it will run, it's in progress. I already run a few scans before the webinar so that I can show you. It just run for a few seconds, but let's spare those seconds. So for each of them, I have access to a summary. So let's go maybe for that one. So that one, I have a summary. So I have those images in the namespace that I scanned. And for example, that Redis Alpine has some CVEs. So I see here the summary of all the dependency of the image. I have, for example, that lib crypto free in that version. It's installed using APK. And I also have access directly to CVEs. So I have BusyBox, a CVE that is high. I have Redis CVE that is critical. I even have access directly to the NVD, so the National Vulnerability Database, to the CVE link, which explains directly what the vulnerability is. I can go back. The raw output is available. If I click here, I can download directly the output, the JSON file. I can save that, and I can open that in my preferred visual editor. What else? I can just show if it finished to run. It's in progress. So the namespace I selected is quite large, so it has to run through all images to unpack all the layers from all images and inspect them. So this one, for example, I also had some a large number of CVEs. I can see exactly the problems here. What's also important is that I can, for each CVE, for each line, I can see which version I'm running and when it's fixed, in which version it's fixed in. So that's also very helpful. I will now go back to the slides just to conclude. In terms of takeaways and call to action, so it's a fact that cybersecurity threats evolve and systems are becoming more and more complex. So industry data suggests that 99% of the code base of all applications contains open source code, which creates significant potential security risk. It doesn't mean that you are at risk, it creates security risks. So a software bill of material scan provides crucial information about the components that makes up an application, which allow organizations to manage and monitor the security footprint of those applications. If you're interested, you can check Tyler's blog. So that's the bit.ly one-click SBOM link that you have on the left. Tyler is the principal engineer that developed that feature in Palette in our tool. You can also go and get started with Palette. Just go at spectrocloud.com and register. You can register by yourself and try and start using our product. And if you, next week is KubeCon Europe. So if you're there, don't hesitate to come to chat with us or just to say hi. If you have any question, we will be at booth S22. Yeah, let me know if you have any question. I will stay for an additional minute. Otherwise, I hope you enjoyed that webinar as much as I enjoyed preparing it. Let me know if you want to use the, I don't see any question. If you want, in the meantime, I can also share, if you want to join our Slack, our community Slack channel, you can just go to spectrocloud.com/Slack and you can register to our Slack channel if you have any question or if you just want to exchange with our engineers and developers. Well, recording and slides will be available after the webinar if you have any questions or if you want to rewatch that. Otherwise, I think I don't see any questions coming, so I think we're good here. Well, let's close it. Thank you for watching. Take care, stay safe, and bye.